Right, so linear inequalities and some more examples, really 3 different examples in this case. So this example is very similar to the one we just did, except with a greater than sign. So let's go ahead and split it up. Before we split it up, let's determine, does everyone see that because it's a greater than, this is going to be an OR problem? Now split it up by writing the parentheses, and then the problem twice. And then throw a minus sign in front. So let's go ahead and solve this one. -4, so let's go ahead and add 4 to both sides. So what we get here is 5x is greater than 20, and x is greater than 4 by dividing both sides by 20. Now, getting rid of this minus sign, you can either do the distribution like we said before, but I'm just going to divide through by this -1, so we can get rid of it right away. So that is -4 plus 5x. Because we divided by a minus sign, the inequality flips. And now we solve it like we did earlier, plus 4. And so we get 5x is less than -12, or x is less than -12/5. So once we have these two, remember you want to draw the number line out. And that's about -2.5. So about right there. So the one on the left, above 4, and then the one on the right is going to be below -12/5. So if we carry down the OR, remember, OR is one, the other, or both. So if we're in 1, starting on the left, it starts at -infinity, stops working till it hits the -12/5. Not included because we don't have an equal sign here. Union represents the OR, and then to the right of 4, which is 4 to infinity. Okay. Now again, remember the OR is very important here because had it been an AND, there is no overlap, so there'd be no solution. So just be very careful. Okay. So the next example is 3n plus 1 over 2 is less than or equal to 5. Okay, so the inequality is less than or equal to, so that is going to be an AND type problem. So let's write that out. And then again, once you know the type, you can easily split it using the parentheses. So parentheses, 3n plus 1 divided by 2, less than or equal to 5, and put a minus in the front, 3n plus 1 over 2 is less than or equal to 5. Yeah. So on the left-hand side, multiplying both sides by 2, you get 3n plus 1 is less than or equal to 10. Subtracting 1 to both sides. What happens when you love math too much? You get 3n is greater than or equal to 9 because no, that's not right. Less than or equal to 9. We only flip the inequality when we're multiplying or dividing by negative. We subtract it, so we don't have to do it. Okay. And then lastly, divide through by 3. So n is less than or equal to 3. This one, if you divide through by this -1 right in the beginning, we have 3n plus 1 over 2. Now that we divided by a negative, we flip it. multiply both sides by 2 again. So we get 3n plus 1 greater than or equal to negative 10. So 3n is greater than or equal to negative 11, and dividing by 3, n is greater than or equal to negative 11 over 3. Yep. Again, get to this point where we have the inequalities, and then write it out on a number line. So we have 1, 2, 3. And then negative 11 over 3 is a little bit under 4, negative 4. Okay. So let's go ahead and color code. Less than or equal to 3 is below 3 or equal to it. And then the one on the right is at the 11 over 3, negative 11 over 3. Or above, which is to the right. Now, bring this down. It is an AND type problem. So AND again is both or where they overlap. And these overlap here and here on the interval negative 11 over 3. Sorry. To 3, but in both cases, the left and the right endpoint are closed circles, so you have to include them in the answer. All right, so let's do one more example. And so I'm going to do it right over here. So the last example is going to be 4 over 3x minus 5 is greater than or equal to negative 4. Now, the reason why this example is in here is because of the fractions. Okay, so start again by determining the type. So determine the type using the inequality. Greater than is an or. And then split it using the parentheses. So 4 over 3x minus 5 is greater than or equal to negative 4, and then negative 4 over 3x minus 5 is greater than or equal to negative 4. So if I add 5 to both sides, what we get is 4 over 3x is greater than or equal to 1. And then we divide both sides by 4 over 3. Now, it is very important to remember your fraction rules. When you're dividing by a fraction, you flip the denominator and multiply it to the top. So these cancel, but on the right-hand side, what I'm going to do is I'm going to flip the denominator and multiply it to the top. And then when you multiply fractions, you multiply straight across. So we can rewrite this as 1 over 1, and then multiply the numbers straight across, or 3 over 4. Now let's do the other one. When you divide by this negative 1, what you're going to get is the 4 over 3 x minus 5, 4 on the right, and then again the inequality flips because we're dividing by a negative 1. Add 5 to both sides. So 4 over 3x is less than or equal to 9. Again, divide through by the 4 over 3. The left-hand side cancels, and x is less than or equal to, remember, flip the bottom, 3 over 4 times 9. So here, x is less than or equal to 27 over 4. So let's write out the solution now. So once you have the inequality, you have to write it out on a number line. So the number line, 0, 3 over 4 is just under 1, while 27 over 4 is, what is that? Just over 6. So it's somewhere over there. Okay. Remember, this graphing is just a visual aid, so you just need to know where they are. So, and make them relatively nice, but it doesn't have to be perfect. So above 3 over 4, and then this one is below or equal to 27 over 4. So let me extend this out. This is an OR type problem. So in one, in the other, or in both. So can we see over here is in the red, in this middle part here is in both, and then in the right-hand side is going to be the blue. So again, this has everything in there. So negative infinity to infinity is the solution.